So in the last class, we were discussing about simple harmonic motion, and we said that simple harmonic motion and circular motion are connected. That means that if we are considering a circular motion, and if we are able to prove that the acceleration that we have is proportional to the displacement, we can say that the motion is more or less simple harmonic in nature. In today's class, what we're going to see is if we are considering an SHM and we are saying that we are considering a circular motion, what will be the maximum and the minimum speed? So a similar image we have done in the last class, and let's just revise this. We have a motion which is circular in nature, and this is basically the top view that we are going to observe. So if we just look from the top, we can see that let's say we have a ball which is placed at this particular position, and after time t, the ball reaches at this particular point. After the same time t, the ball again reaches at this point. That means we have the angular displacement which are equal. So you can say, okay, you can just imagine that this distance, so this distance, this, and this, which are the angular displacements, are equal. Now, if we just look from a linear point of view, what we can do is we can drop a circle, drop the circle perpendicularly and look into the position on the side view. So if you see, we have dropped it here. If we look for this particular case, we can see that it's here. So you can see that even if in the circular space it is equally spaced, but in the linear position the distances are different, and for this we can say that it drops exactly at the center. So we have the image at the center. So as we go along from the right to the left, we can see that the distance of the ball keeps on increasing as we go towards the center, but the displacement along the circular arc are equal. Now why does that happen? So if you just want to write down the statement for that, the first thing is that we observe is along the arc distances are equal. Along x and y, the distance keeps on increasing with time. That is, the velocity increases. Now, you see, the time that it takes traveling from, let's say, point A to point B to point C, and point C to point D are the same. So that means the time that it takes from traveling from this point to this point, or this point to this point, or this point to this point remains the same. But still, the distance changes. So the only factor that can bring about this change is nothing but the velocity. That means that this ball, as it keeps going towards the mean position, the velocity will keep on increasing. So we know velocity is equal to distance divided by time, or we can say that the distance is equal to velocity into time. Now we are saying that the time will more or less remain fixed for each of these positions from one point to the next point. That means the only factor that can change because of which the distance changes along the linear scale is velocity. So we can say that the x and y distance keeps on increasing with time, that is, the velocity increases. I hope you get this point. The next point is the maximum velocity is obviously at the mean position. Now, even if you consider a pendulum and look into its motion, and if we just consider this, we know that the potential energy will be maximum at the ends. So that means the velocity at the end is 0. This side also the velocity is 0, but at the center, along the mean position, the velocity is maximum. Now you know, because of the conservation of energy, the potential energy gets converted into kinetic energy, and if we consider a point somewhere in the middle, it will basically have both combination of potential energy plus kinetic energy. So the entire potential energy gets converted into kinetic energy at the mean position. That means the velocity here should be maximum. So in this case also we can see that the velocity is maximum at the mean position. Now in the last class we did see that the velocity is actually given by minus omega a sine of omega t. So you can basically consider the displacement relation to be a cos omega t, and then you can differentiate it with respect to time, and you get the velocity. Now my aim is to find out what is the minimum and the maximum velocity. So if you want to calculate the minimum velocity, logic defines that it should be minimum at the extreme ends, because at these two extreme ends the velocity is 0. Now in this case, this can only be 0 when sine of omega t is minimum. So velocity is minimum, we can say, when sine of omega t is minimum. Now we know that the minimum value of sine of omega t is -1. So if I put -1 here, it will become omega a. So the velocity is not zero or not minimum. So that means we can say the minimum value of sine omega t that will be with respect to this particular case is nothing but 0. Now when is sine equal to 0 means that the phase omega t must be 0 degree or 180 degree. Now which are the two positions where it is 0 degree only? Here it is more or less 0 degree, and in this case it's 180 degree. So that means at these two extreme positions the velocity is 0. Even if you compare it with a pendulum, we know that the extreme positions the velocity will be 0, right? So that's the position for the minimum velocity. Okay, so we can say at 0 degree or 180 degree, okay, the velocity is minimum. So this is important. Velocity is minimum. So we found out what is the minimum velocity. In a similar way, we can also find out velocity. Now, if you just look into the image, and if I just tell you what are the angles here, you see this, the angle would, or if you go counterclockwise direction at this particular position, degree. So in this, we can really find out what is the maximum velocity. So if I do the calculation for maximum velocity, that means V max for maximum velocity, V max, and this is only possible when sine of omega t is maximum, or you can say omega t is equal to 90 degree or 270 degree. How? So if it's 90 degree or 270 degree, we know sine of omega t is equal to -1. So that's sorry, it's plus. So it will be +1, okay, or plus -1. We can take that, okay, any of these values, and therefore we can say that maximum velocity
-1. In this case, I can say that this is minus omega a sine omega t. So it will be -1, so it will be plus omega a. So I can say that the max is your max velocity that is possible. And this is your minimum velocity, right? So minimum velocity is obviously minimum velocity is 0. So maximum velocity in this case, minimum velocity in these two cases. So that's it for this class. In the next class, we are going to discuss about